It's Flashcard Fridays. I'm Gabrielle Burchak, your host. Last Tuesday's episode was about photographing thoughts, but today I'm going to talk about those moments where you wish you could have just thought about the subject better and captured those fleeting ideas in your head, especially when you're trying to learn something new. But first, a quick word from my advertisers. So today is a toolkit episode. I'm going to use 3 flashcards to make thinking steadier across subjects, including math, chemistry, and everyday decisions like asking for a raise. A lot of us were taught to treat learning like absorbing information. We read it, we highlight it, we repeat it, and then hope it sticks. That approach can work for some things, but it often breaks down the moment you hit material that is abstract, layered, or unfamiliar. So here are our 3 flashcards. First, the system card. Second, the cold recall card. And third, the fuzzy spot card. Each card is designed to pull you closer to understanding without turning learning into judgment about your worth, because you have worth. Today, we're going to treat confusion as information, we're going to treat mistakes as feedback, and we're going to treat thinking as a skill that can be built. So let's start with the first card, the system card. Let's say you receive a prompt, and the prompt is, what is the system? What are the key variables, and what constraints or rules govern it? With this card, you can move from a list of facts to a working model. A list can be hard to use because it doesn't tell you how the pieces connect. A system is easier to use because it gives you a structure. When you can name the system, you can reason, you can predict, you can test, you can correct. A system has parts that interact. It has variables that change. It has constraints that limit what is possible. It has rules that tell you what follows from what. As a result, when a topic feels scattered, it often means the system has not yet been named. The system card helps you name it. So I'm going to run this card across a few subjects to show you how it works. Let's talk about math. Think about averages. If you treat an average as a calculator button, it can feel like a trick you either remember or you do not. The system card shifts the question. What does an average model? It models a typical value by compressing many numbers into one. The system is the data set plus the rule you choose. The key variables are the values, how many there are, and how spread out they are. The constraint is choosing the right average. Mean, median, and mode tell different stories, and outliers can pull the mean. In physics, the system is a specific setup, like a block on an incline connected to a hanging mass. Mechanics is the toolbox. The variables include force, mass, acceleration, and time. Constraints might be friction or a taut string. The governing rules include Newton's laws. Once a system is named, a quick diagram often tells the story. In philosophy, the system is an argument. The variables include identifying premises, conclusions, definitions, assumptions, and inference rules. The constraints are logic and consistency. When you see the structure, you can test whether the conclusion actually follows. So here's a small practice you can do in under 2 minutes. Using the system card, when you begin a topic, write 3 sentences. First, the system I am studying is, and then you answer that question. 2, the key variables are, and then you answer those. And then 3, the constraints or governing rules include, and then you answer that part. If you can't answer one of these yet, that's not a problem. That's a sign you found the correct doorway. The goal is not speed. The goal is orientation. This can help your brain click. Now, flashcard number 2, the cold recall card. Let's say we receive a prompt and the prompt is, can I produce the explanation or solve a fresh problem without looking? And can I do it again later after a delay? The cold recall card addresses a common trap. Familiarity can feel like mastery. And through cold recalls, familiarity can give us authority. When you reread notes, your brain recognizes the material, right? The recognition feels smooth and reassuring, but recognition is not the same as being able to generate the idea on demand. Cold recall is a supportive test. It tells you what you can actually produce right now. It does not insult you or label you. Instead, it gives you a signal. So here's what it looks like in real life. Let's say you're getting ready for a job interview. You've done your research and you have an idea what the hiring personnel is going to ask you. So you write down talking points and your responses. Then you put your notes away and answer the first question out loud, which will probably be, "Tell me about yourself." You have written a 1-minute story about a challenge you handled and why that makes you a great candidate. In this first run-through, you are not aiming for perfection. You are aiming to keep your structure and your point. Okay, let's say you're giving a speech or a presentation. Try closing your slides and delivering just the skeleton, which is your 1-sentence thesis, your 3 main points, and your closing takeaway. Then you practice the first 20 seconds 3 times because nerves tend to erase memory right at the start. If you can keep the structure, you can recover even if you forgot a line. How about asking for a raise? This is where cold recall becomes protection. You put your notes away and practice a simple structure. You ask in 1 sentence, 2 measurable evidence points and a specific number or range. Then you rehearse responses to predictable pushback. Like they would say, "It is not in the budget. Now is not the right time," or "We can't adjust compensation." You are not rehearsing to be aggressive. You are rehearsing to stay coherent and to get that raise. Here's a simple routine you can use. Learn a small unit, then set a timer for 2 minutes. Without notes, practice out loud. Then, and this part matters, return tomorrow and do the same 2-minute recall again. That delay forces your brain to rebuild the idea rather than echo it. You can now recognize your own points and produce them under pressure. If cold recall feels uncomfortable, that is expected. It's supposed to be a little effortful. Effort is not proof that you are bad at it. Effort is often the mechanism of learning. So now cold recall does something really important. It reveals gaps. It reveals weak links. That is precisely what we want because our third card is designed to repair those weak links without turning study into a grind. Flashcard number 3. The prompt you can use for this is, where exactly does it go fuzzy? What is the likely failure point? And what is the smallest repair that changes the outcome? This card is about troubleshooting. It takes you from everything is wrong to this specific step is failing, and that shift is where progress lives. The fuzzy spot card has 3 steps. First, name the precise fuzzy spot. Second, identify the mistake or missing link. And third, apply a minor repair that changes the outcome. Here are 3 examples. Let's say you're trying to audio engineer a project. If you've ever worked with audio, you know that "it sounds bad" is not a diagnosis. The fuzzy spot is more precise. Maybe the harshness shows up only on S sounds, or the distortion only appears when the singer gets loud. The minor repair is not 10 new plugins. It is bypassing 1 step at a time, A/B testing your chain and finding the first point where the problem appears. Fix that point, then test again. Boom! You're 1 step closer to finding the fuzzy spot. Another example could happen at work, where a project is stuck. The boss calls you all in and announces, "We are behind." It can sound like a motivation problem, but it is often a blockage problem. The fuzzy spot might be that the team is waiting on 1 decision about the scope, and 2 tasks can't start until that decision exists. The quickest repair is not more meetings. It could be 1 short decision-making meeting with options, including a team leader to get the scope from the vendor and then a prioritized task list. Boom, the project is moving forward. Okay, here's a familiar problem that can use the fuzzy spot card: personal arguments. Let's say you constantly argue with your roommate or partner about chores. This might sound familiar. We always fight about chores. Well, that is a foggy summary. The fuzzy spot is usually a mismatch in definitions. One person thinks later means tonight. The other thinks later means this weekend or even next month. The repair is not a longer argument. It is an explicit agreement. What, quote, done means, and when you can both agree on when it will be done. boom, you suddenly like each other again. Isn't that awesome? I love that card. The fuzzy spot card is simple. Locate the exact failure point, make the smallest repair, and that changes the outcome. So now that we have 3 cards, let's put them in a loop. First, the system card builds the framework. Ask yourself, what is the system? What variables matter? What rules constrain it? Second, there's the cold recall card that tests the framework. Ask yourself, can I produce it without looking? And can I do it again later? Third, the fuzzy spot card repairs the break. So ask, where does it turn vague? What mistake is happening? And what is the smallest repair? Then repeat the loop. So here's a challenge for the week. Pick one thing you are already doing, something real, a conversation you need to have, a meeting you need to lead, a problem you need to solve. First, run the system card. Name what you are working with, what matters most, and what rules you cannot ignore. Second, run the cold recall card. Put your notes away and see if you can say it cleanly. Then try again tomorrow. Third, run the fuzzy spot card. Listen for a moment where your thinking gets vague and then make the smallest repair that changes the outcome. Keep it small. One topic, one pass, 10 minutes. If you want, write the 3 prompts on a sticky note and then use them once a day this week. See how it works. Thank you so much for tuning into Math Science History. If you enjoyed this podcast, please share it with your friends and leave a rating and a review. Those reviews really do help the podcast grow. And if you are interested in reading more about these tools for thinking with clarity, please come visit me at Math Science History, where I provide the sources that I used to write this podcast. And while you're there, click on that coffee button and make a donation. Thank you so much for tuning in. And until next time, carpe diem.